Hello, beautiful people, and welcome. In today's video, we are going through the Integrated Math 1, Chapter 6, Practice Exam. Question number 1 is asking you to simplify the following expressions using exponential properties. Negative exponents are not allowed in your answer. Question number 1, we're going to start off with separating all of my letters and numbers, my bases, with a multiplication symbol. That's going to be our step number 1 with all of our questions in using our exponential properties. After you have separated them using the multiplication symbol, you're going to combine the ones that have the same base. And before we combine, we're just going to write them next to each other, and then we're going to combine. So I'm noticing I have bases of y's, bases of x, and then I have kind of like a random 2 base. That's just a base that's a number, so I don't have any other bases that are numbers to combine it with, so the 2 stays as a 2. Now for the other ones, I do have x's, and I do have multiple y's here that we're going to need to combine. Now, when we are combining things that have the same base, like y's and like x's, that means when we are multiplying the same base, notice that we did put in that multiplication symbol, we are going to be adding the exponents together. So 2 stays, we're not doing anything with that 2. But now we have 1 base of x, and 3 plus negative 1 is a positive 2. I was going to say negative, but it's not. It's just 2. 3 minus 1. And then we have negative 3 and a negative 1, which gives us a negative 4. Negative exponents are not allowed, so no negative exponents are allowed in your answer. So I have a negative exponent, which means this is not my answer. It's not allowed. So what that means is we're going to use a property that deals with negative exponents. And a negative means that you flip the base. You see this y, you're going to flip it and put it into the denominator. So we are left with 2x squared. And I'm going to take this y, take the 4 without the negative, and I'm going to place it in the denominator. This is our answer. Okay, so again, be careful with that. We're going to take this y, this 4, and we're going to put it on the bottom because we had that negative exponent. For the second one, notice that we have parentheses. So step number 1 is still going to be the same. We're going to place our little multiplication symbol in between everything that we have. But notice we do have parentheses, and outside of that parentheses we have a 3. So to deal with that parentheses, we're actually going to put everything on the inside. Ooh, that should be an N, not an M. But everything on the inside of the parentheses gets its own parentheses. So an M gets a bubble and an N gets a bubble. And then this N is cubed. Now, outside of our parentheses, we did have a 3, so we are going to be placing an exponent of 3 outside of our parentheses. Now, in the denominator, I did not have parentheses, so they do not get parentheses. When we have a missing exponent, for example, on M, the exponent is 1. So if we have a missing exponent, our exponent is 1. Next, when we have an exponent being raised to an exponent, just like we have here twice, we're going to multiply those exponents together. So this is how it's going to look like. We have m1 times 3 times n3 times 3, and then in the denominator, we did not have parentheses, so we just copy it down. Let's go ahead and multiply this. 1 times 3 is 3. 3 times 3 is 9. And again, we're just copying down that denominator. Notice that we have m's top and bottom and n's top and bottom. We're going to separate that out into two fractions. The m's get their own fraction, the n's get their own fraction. Next, we're going to be using the quotient property, which says that if I have the same base and I am dividing, that means I'm going to be subtracting my exponents. So we're going to be bringing this m to the top, and we're going to be having a little bit of a setup here. Notice what I'm doing in the exponent spot. And I'm going to be writing in top minus bottom. Top is 3 minus bottom is 2. Top is 9 minus bottom is 2. And so now we're going to subtract. 3 minus 2 is 1. 9 minus 2 is 7. And I'm going to ask myself, do we have any negative exponents in this answer? And no, nothing's negative. Therefore, we are done. Remember, negatives are not allowed in your answer. If you want to eliminate that one and just put m, that's okay as well. Moving on to question number 2. Identify the following exponential function as exponential growth, exponential decay, or neither. When we are looking for exponential growth, decay, or neither in an equation, I'm going to take a look at our b value, and we're going to take a look at the a value. Now, what we want to know from a, is it positive or negative? Since it is positive, then b is now what determines if this is a growth versus a decay. If a was negative, then immediately our answer is neither. But since a is positive, we're taking a look at the size of b. b is a fraction. It is positive. It is also less than 1. So we have exponential decay. Identify the asymptote in the following function. Asymptotes are our k values. So we're looking at the end. If this number is missing, that means our number is 0. Now, when you do this, you have to write the asymptote in the form of an equation. So y equals 3 is the equation of our asymptote. Describe the transformation of 7 to the power of x into g of x is equal to negative 3, 7 to the power of x minus 2 plus 4. So they want two different things here. They want to know what the negative represents. What they're asking of you is this negative here. And the negative out in front of an a value, is a reflection across the x-axis. Now, what they're talking about for the part 2, the 2 represents, they're talking about this 2 right here. So for that 2, we see a negative 2. That means we have a positive 2, which means we're going to go to the right. You can say shift 2 to the right. You can say right 2. You can say right 2 jumps. I'm okay with any of that as long as it says right. Moving on, it says solve without a calculator. You must show all work for credit. So what this is asking you to do, prove you know 2 things. 1, your understanding of exponents, and 2, your understanding of what a negative exponent is. So an exponent tells you how many times to write that base. So if I have a 4, that means I'm going to write 2, 1, 2, 3, 4 times. Now, options, it says solve without a calculator. You either have this memorized or you can multiply two things at a time. So 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So I want to see all of this work, must show work for credit to prove that you know what exponents are. Now this question right here with the 1/3 is asking you not only to prove that you understand exponents, but also that you understand negative exponents. Here we do have a negative exponent. And what a negative exponent does is it flips the base. Our base is 1/3, so we're going to make that into 3/1, and then we're going to create a positive exponent of 2. Now, I am being extra with that plus, but this is a positive exponent of 2, which means that we have 3/1 once times 3/1 twice. And when you're multiplying fractions, you're going to multiply straight across, which means we have 3 times 3, 1 times 1. And yes, you can eliminate that 1, but I'm just showing you. We got 9/1. 9 divided by 1 is just 9. Again, we're going to be looking for, do you know how to flip the base because of that negative? And do you know what it means to have an exponent of 2 versus an exponent of 4? Moving on to the next question, question number 6. Once again, we are asking you to do some calculations without a calculator, proving you understand exponents. First thing you're going to do is, here's your entire function. Now, I'm going to highlight everything just so you know what your function is, which means that we do have a k value of -2, so we don't forget that. You're going to start by copying down the function, and anytime we see an x, you're going to have your input into that spot. So here, my input is 0. I still have a -2 in my exponent, and then I have a -2 that's not an exponent. Again, I have an input of 1, -2 in the exponent spot, and a -2 that's not in the exponent spot. Again, 1/4, 2 minus 2, minus 2. 1/4, 3 minus 2, minus 2. 1/4, 4 minus 2, minus 2. Now make sure you're writing that k value of -2 of this -2 a little extra. Next thing you're going to do is you're going to simplify, evaluate, subtract in your exponent spot, so that way we can just simplify. So we got 1/4, 0 minus 2 is -2. 1/4, 1 minus 2 is -1. 2 minus 2 is 0. 3 minus 2 is 1. 4 minus 2 is 2. Next, we're going to ask you to show us if you understand what a negative exponent does. A negative exponent flips the base, so I only have 2 negatives. So I'm only going to flip this 1/4 once, making that exponent positive, and twice, making that exponent positive. Here, we need to show proof of understanding that any base to the power of 0 is 1. Here, I need to show proof that I understand what exponents are, so I'm writing 1/4 once. Here, I'm writing 1/4 twice. Now, I did not flip this base because my exponent was not negative. Here, I need to show continuing proof that I know what exponents are, so I'm going to do 4 times 4. You can put 1 underneath if you'd like. Here, I'm just going to do 4 one time because I have an exponent of 1. And so now we start calculating. 16 minus 2 is 14. 4 minus 2 is 2. 1 minus 2 is a -1. These two you need to calculate somewhere other than here because you need to create common denominators. So I get 1/4 minus 2 over 1. I'm going to multiply top and bottom by 4 because I have a denominator of 4. 4 times 2 is 8. So I get -7/4. Here I do need to multiply first, so I got 1/4 times 1/4 minus 2, which gives me 1/16 minus 2 over 1. I'm going to multiply top and bottom by 16. 1/16 minus 32 over 16, which gives me a -31/16. And now we're graphing. What is the asymptote? We're going to take a look at our k value. Our k value here is -2, so y equals -2 is my asymptote. For the domain, immediately we just write down -infinity to +infinity. One of the characteristics of an exponential function is that the domain is always from -infinity to +infinity. The range is dependent on the asymptote, so let's find the asymptote. Make sure your asymptote extends out of your graph. And let's plot some points. I got 0 and 14. I don't have space for 14, so I'm going to guesstimate, make it here, about here-ish. We got 1 and 2, 2 and -1. And then I don't know what -7/4 is, so we're just going to type that into the calculator. That's about -1 and a little bit. And then we'll do the same thing with -31/16, which is -1.9. So almost at -2, but remember, we cannot touch the asymptote. So when we're drawing this out, make sure to get super close, uncomfortably close to your asymptote, but not actually touching. And also make sure that you are not curving back up. If you curve back up, that means you have a different type of function and it wouldn't be considered exponential. So make sure you're getting super close to your asymptote. Now, going back to the range. For the range, you're going to take a look at what value you have, and that value for us is a -2. And then notice that we are coming down from +infinity. So we have +infinity all the way to -2. Now, smaller numbers go to the left. That is why we're writing -2 first. The bear population increases, keyword here. That means we have a growth. You're going to have to look out for keywords. At a rate of 2% per year. There are about 1,573 bears. Write a function that models the bear population. So we are going to write out a growth equation with 1,573 bears, 1 plus our rate. We need to convert that rate into a decimal. So remember, 2 jumps to the left. And then you can use X or you can use T. They did not state that they care. So we're going to put T for time. Now again, most of you left this type of answer on your quiz and I did accept it, even though it was technically incomplete. So you want to simplify what is on the inside by adding. And the reason we are adding is because we have exponential growth. This is a growth function, so we need to add. If it was a decay or decreasing, then we would have subtracted. How many bears will there be in 10 years? Here's the thing, the difference between the quiz and this. We want to be careful with the rate that they give us and what they're actually asking. The rate was per year, and they're asking for years, which means that T is in years, and they're asking in years, so we do not need to create any conversions. All we need to do is take our equations and put 10 in the T location. We're then going to pick up a calculator. We're going to type in my numbers, our numbers, with an exponent of 10. And again, we want to round accordingly. So I'm going to write these numbers down. This is what I have in my calculator. When we are rounding to whole numbers, we are going to be taking a look at this number here in our tens place. This is a 4. Now I understand there's a 7 behind it. We kind of don't care about that 7. My focus is at this 4. Since it is a 4, we are going to keep that 7. So we have 1,917. What are we talking about? We're talking about bears. Next one. Question number 8. We have a $25,000 car, which is going to be decreasing its value by 16.7% each year. We're going to write a function that represents that situation. So we're starting out with $25,000 car. Keyword here is decreases, so we're going to have a decay. We have a rate of 16.7, which we need to convert to a decimal. So move 2 jumps to the left. And they are telling us that we are having a rate in years. So let's write a decaying function. We start out with $25,000 vehicle. 1 minus, because we have a decay, our rate is 0.167. And it doesn't tell us if they want it in terms of x, so we're going to keep it in terms of t. Again, most of you left this type of answer on your quiz, which I did accept, but on the test, make sure that you simplify this equation by just subtracting what's in the inside. So you have y equals 2500, 0.833 to the power of t. If you put x, that's okay. I don't mind. What is the car's value after 5 years? This is where years and years is important. Again, as we saw on your quiz, sometimes they give you a rate in months, they ask in years, so you got to be careful. So, since we have years and years, we're going to take our equation, and we're just going to put the quantity of years, which is 5, in our time spot, in our exponent spot. We're going to type that into our calculator and write out our answer. So we have 1002.686149. Again, I'm writing all of this out to show you. Since we're talking about money, we're going to take a look at this third number. Since this is a 6, we're going to round this 8 up by adding 1. So we have $1,002.69 is the cost of our $25,000 car is now worth $1,000. Scary. All right. Question number 9. How much money will you have in 8 years? Hold on, we're talking money. We want to know how much money in 8 years. If we invest $4,000, okay, so we're starting with $4,000. We have a rate of 3.5%, and it's compounded quarterly. And I'm going to draw an arrow to this quarterly. These two go hand in hand. If you're seeing the word compounded, that means you're going to be using the compounded formula. The quarterly that's next to it could be quarterly, semi-annually, monthly, yearly. Let me turn my phone off. I apologize. So it could be different things. We are going to be doing this question for quarterly. Quarterly means it happens 4 times a year. Next, let's write out our formula. Y equals, what's our starting amount? We start at 4,000. We're going to multiply that 1 plus. Now we have a fraction. On top of that is our rate that we are going to convert by shifting 2 jumps to the left. So our rate is 0.035. And then this quarterly. Quarterly means it happens 4 times a year. So our n goes in the denominator, and I'm going to put separate parentheses around here. And then we have an exponent. I'm showing you a caret because that's what you're going to type into the calculator. And here you're going to once again do your quarterly of 4 times, and then here's your years, your 8 years. You're going to type all of that into the calculator and press enter once. Let's see where I have no glare. No glare, right about here. Okay, so $4,000, open, 1 plus open, 0.035 divided by 4, close it, caret, open, 4 times 8, close it, enter. Okay, so we have 5286.07741. Again, we want 2 decimal places for money, so we are looking at this third number of 7. Since this is a 7, we're going to round up to an 8 here. So our $4,000 in 8 years with a 3.5% interest at a rate compounded 4 times a year will give us $5,286.08. Question number 10, identifying the following sequence as arithmetic, geometric, or neither. Make sure to state your reasoning. Okay, so this is where in class we did a T-chart. And we wrote arithmetic, test, and then geometric. For arithmetic, we did our setup. And notice I'm not putting any numbers in there. And then geometric, we did our setup. If we end up having a common difference, then we have an arithmetic sequence. If we end up having a common ratio, then that means it's geometric. If it's not arithmetic and it's not geometric, it's a neither situation. So let's take our right numbers, subtracting our left, our right numbers, subtracting our left, and our right number, subtracting our left. Let's do this one first. If something is arithmetic, you do not need to check for geometric. It's not going to be both. 9 minus 1, that's 8. 25 minus 9, that's 16. And immediately, because these are different, no, it is not arithmetic. Not arithmetic. And why is it not arithmetic? No common difference. So now that means we're going to check our right divided by our left, our right divided by our left, our right divided by our left, and our right divided by our left. 9 divided by 1 is 9. 25 divided by 9, this is 5 times 5. This is 3 times 3, so this cannot be simplified. 49 is 7 times 7. 25 is 5 times 5. This is, again, cannot be simplified. So if you take a look at our numbers, you'll notice that no common ratio, not geometric. So the answer, is it an arithmetic sequence? No. Is it a geometric sequence? No. Is it neither? Yes. So our answer is neither. Now, make sure to state your reasoning. This is the reasoning. You need to show proof that it's not arithmetic. You need to show proof that it's not geometric. And this is your reasoning for your neither answer. Let's do exactly the same thing here. We want our arithmetic. We want our geometric. Again, here's our setup. We're going to shift our papers up. And then here's our geometric. We do our right and our left, our right and our left, our right and our left. And then we're going to type that into the calculator. Question came up, do we need our parentheses? Yes. If we have things like double negatives, not common, but double negatives, then we want parentheses. So I get a -3 here, and we get 12 minus a -6. We get a -6, and again, immediately this is not arithmetic because I already do not see a common difference. Notice that we are not the same number. No common difference. So now we test for geometric. We take our right and our left, our right and our left, our right and our left. Negative, negative goes away, negative, negative goes away, negative, negative goes away. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. So, yes, geometric. How do we know? Because our common ratio is 2. Hang in there, beautiful people. Almost done with this. Question 11. Given the following sequence, write the explicit rule, then find a sub 8. So we don't know what type of sequence this is, so we have to first determine, is this arithmetic or geometric? Now, you can do the table if you'd like, or you can look at the pattern and see what the pattern is. For me, I'm going to do the quick little table. I'll do the table up here. Here's my arithmetic. Here's my geometric. Again, our right and our left, our right and our left, and our right and our left. Quickly type that into the calculator. We get -20 minus a -4. I get a -16. -100 minus a -20. I get -80. I'm not going to check the next one. Not arithmetic. So I'm going to check geometric. Again, right divided by left, right divided by left, and right divided by left. Let's see if that has what I need to determine this is geometric. So -20 and 4, -100 and -20, -500 and -100. -20 divided by -20 divided by -4, I get a 5. -100 divided by -20, I get a 5. Good. And -500 divided by -100, I get a 5. Good. So we have a geometric sequence with a common difference of 5. So that means I am writing my explicit rule. A sub n is equal to a sub 1 times r to the n minus 1 power. And so for geometric, we have a sub n we keep. A sub 1 is the term in the first position. So it's the first number you see is a sub 1. So for us, it is -4 times your common difference is what we found here with our check. And our common difference was 5. Now your n minus 1, you just keep the same. You don't change anything. Now, when they are asking you to find a sub 8, this 8 is what you're going to put into your formula. Now, they already gave you an a sub 8 here. So all you're going to do is you're going to type this in, and I'm going to put it in a thinking bubble because this is a calculator portion. You're going to type in 8 minus 1 in parentheses, or you can type in 7, but I usually don't do that. So what I do is -4 times open 5, close, caret open 8 minus 1, close, enter, and you're going to write that number down. So -312,500. Given the following sequence, write the explicit rule, then find a sub 52. Again, is this arithmetic? Is this geometric? It could also be a neither. So let's do I'm trying to find space. Let's just do an arithmetic test here. If it doesn't work, we can erase it and do geometric. Our right minus our left, our right minus our left, and our right minus our left. 225 minus 25, I get 200. 425 minus 225, ooh, I get 200. And if this one works, that means yes, it is arithmetic, and it does. That means we have a common difference of 200. That means this is arithmetic. That means be careful, we have to do a little bit more with the explicit rule. The explicit rule is a sub n is equal to a sub 1 plus d times n minus 1. Keep the a sub n. A sub 1 is the term in the first position. So our term in the first position is 25. And then we have our common difference. Our common difference is 200. And then you're going to keep your n minus 1. We do need to distribute that positive 200 onto n onto n and negative 1. So a sub n is equal to 25 plus 200 n. 200 positive times a negative is a negative 200. Last step here, you're going to combine these two terms together. Use a calculator if you need to. 25 and a negative 200 is a negative 175. So our explicit rule is a sub n is equal to 200n minus 175. To find your a sub 52, you're going to take that 52 that they are asking, and you're going to put that 52 into your equation. Here's a thinking bubble. This is what I'm going to type into my calculator. 200 times 52 minus 175. This is my formula. This is what I type in. 200, open, 52, close, minus 175. And I get 102,000. Just kidding. I get 10,225. I misread. 10,225. 3 more, and then that will be it. Solve the following equations. These are exponential equations. Level 1, 2, 3, and 4 style questions. First question we see two bases, quite literally the number 2, but we have a base and a base that are the same, which means we're going to take our exponents, we're going to bring them down, set them equal to each other. We got a negative 3v is equal to negative v minus 2. I'm going to do a dotted line, add v to both sides. I get a negative 2 times v minus 2. These go away. And I'm going to divide by a negative 2 both sides. V is then equal to 1. This is a level 1 question that did happen rather quickly. If you need to rewatch that, please rewatch that. Again, level 1, same base, eliminate those bases. For B, we have 125, 5, and 5. Notice that we do not have the same base. We have 125, and then we have 2 5s. So this could be a level 3 or level 4. It just depends, can we create 125 from the base of 5? So if I double check my calculator here, that works. You got to check it first. Not the number I need. Yes, the number I need. So that means this is a level 3. We're going to open up 125. There are no exponents on that number. I'm going to copy down everything else. And instead of writing 125, I'm going to look into my calculator and I'm going to write 5 to the power of 3. Now that I have the same bases, this is now a level 2. This is not a level 1. You cannot eliminate the bases unless it's a level 1. Your next step is to combine. When you have the same bases, you're going to add the exponents together. So you will have one base of 5 You're going to have 3 from here, and you're going to have 2n plus 3 from your second exponent. And then copy down on the right-hand side. Now that we are at a level 1, we can then remove the bases, bringing down all of our exponents. 3 plus 2n plus 3 is equal to negative 3n. Combine like terms on the same side first. So we have 2n plus 6 is equal to negative 3n. I'm going to subtract 2n on both sides. 6 is equal to a negative 5 times n. Divide by negative 5, divide by negative 5, running out of space, n is equal to a negative 6/5. If you can simplify your fraction, you must, but it has to be remaining as an improper fraction. I don't have space for c, so I'm going to move on to a separate sheet of paper and copy down that last example. We have 36 to the power of 3v times 216 to the power of negative 2v plus 2 is equal to 216 to the power of 2 minus 2v. Just like we did in B, this could be a level 3 or it could be a level 4, just depends. If we can create 216 from a base of 36. So 36 caret 1, we're going to double check, make sure our calculator is working. Then I'm going to go up and change that to a 2 and see what happens. Notice that the number the calculator gives me, oops, there it is. Notice that the calculator gives me a very large number and not 216. This is too big already. That means that no, we cannot create 216 from 36, meaning this is a level 4 question. In a level 4, you're going to change all of the bases. You have a choice. You can either start with 2 and just use guess and check, or you can be like, okay, which one do I think it's going to work? I'm going to choose 2 and see if that works. So double check my calculator. Let me get the glare out of the way. There it is. 2 caret 1, that works. 2 to the power of 1. 2 to the power of 2, 4. And I'm going to keep going, changing these numbers until I get these. Sometimes it will happen, sometimes it won't. 32, nope, I need a 36. Too big. Notice that if I have 2 to the power of 5, that's 32. But if I do 2 to the power of 6, that's 64. That means I have skipped 36. 2 cannot be my base because I cannot create 36 from a base of 2. So now I'm going to go back and I'm going to try 3. So we're double checking. 9, that's not it. 27, that's not it. 81, again, I skipped over 36. It didn't work. Let's try 4. Let's see, 16, 64, again. That 36, I still don't have a 36. Again, 5. I don't think 5 is going to work because if you take a look at my numbers, they're not multiples of 5. So that means I can't use 5. But again, 125, do you see that? It's still not 36. So now let's try 6. Finally, I got a 36, but that's not what I technically am okay with. I still need to change 216. So if I can get 216 from a base of 6, then we're solid. Perfect. Wonderful. So finally, we got our base of 6. So here's what we do at a level 4. Open, copy your original exponents. So right now, all I'm doing is I'm opening up parentheses and I'm going to copy down the original exponents that I have. I'm not writing anything inside. Next, I am going to say, okay, 2 to the power of, let me take that back. It was not a base of 2, it was a base of 6. 6 to the power of 2 was 36. 6 to the power of 2, make your 6 a little twirly, was 36. So instead of writing 36, I'm writing 6 squared. Then it was 6 cubed. That ended up being 216. And 6 cubed, that ended up being 216. Next, again, this is very important. You're going to copy down the base and the exponent and move the parentheses around your original exponent. It's kind of like shifting and picking this up. We are right now, by doing this, applying the power to a power property that says if I have something with an exponent and it has its own exponent, we will then multiply those together. And so by moving those parentheses, we are now multiplying 3 times 2 minus 2v and 2 times 3v and 3 times negative 2v plus 2. Again, we cannot drop the bases here. This is not a level 1. This is a level 2. So we need to combine first into one base. And this just happens by copying things down. You're not actually going to be adding anything. So I'm going to be writing that plus, but I'm not really doing anything with it. I just need to get it to be a level 1 question. Now that I have a level 1, then I'm just going to remove my bases and copy down my exponents only. So now we're here. 2 times 3v plus 3 times negative 2v plus 2 is equal to 3 times 2 minus 2v. The reason we have those parentheses is because sometimes you will need to distribute, and you are going to distribute when you have a binomial in your parentheses. So 3 goes to the negative 2, 3 goes to the positive 2, 3 goes to the positive 2, 3 goes to the negative 2. Here, this is just 2 times 3. We got 6v plus a negative 6v, this is a positive 3, times 2 is positive 6 equals 3 times 2 is 6. 3 times negative 2 is a negative 6v because it has a v. Dotted line, combining like terms on the same side first. So 6v minus 6v, that's 0 v's. I'm going to remove that 0v. I'm just showing you that we have no v's. That's gone. I'm going to subtract 6 on both sides. And notice what happens. Let me bring down the negative 6 times v. 6 minus 6 is 0, but 6 minus 6 is also 0. I can't have nothing on this side, so I am having to write that 0. We are still not done removing things from v, so I'm going to divide by negative 6. V is equal to 0 for my answer. All right, beautiful people, that is it for this video. If you made it towards the end of the video, thank you so much for your time, and I will see you in the next one. Bye!